For a WG grounding electrode conductor, also known as a GEC, an electrode bonding jumper is required to be bare. This means it cannot have any insulation, including green insulation, applied during its manufacture. The purpose of the bare conductor is to ensure a reliable and low impedance path to ground. Firstly, let's talk about the grounding electrode conductor. The grounding electrode conductor connects the system grounded conductor, which is typically the neutral, or the equipment grounding conductors, or both, to a grounding electrode. This grounding electrode could be a ground rod, a metal underground water pipe, or a concrete encased electrode, sometimes referred to as a U for ground. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The National Electrical Code, or NEC, Table 250.66, dictates the minimum size of the grounding electrode conductor based on the size of the ungrounded service entrance conductors or equivalent area for parallel conductors. For example, if you have copper service entrance conductors that are 4/0 AWG or smaller, the minimum size copper grounding electrode conductor is 8 AWG. If the service entrance conductors are larger than 4/0 AWG up to 350 kcmil, then the grounding electrode conductor must be at least 6 AWG. If the service entrance conductors are larger than 350 kcmil up to 600 kcmil, then the grounding electrode conductor must be at least 4 AWG. If the service entrance conductors are larger than 600 kcmil up to 1100 kcmil, then the grounding electrode conductor must be at least 2 AWG. If the service entrance conductors are larger than 1100 kcmil, then the grounding electrode conductor must be at least 3/0 AWG. These requirements are outlined in NEC Table 250.66. It's crucial to refer to this table to ensure the grounding electrode conductor is appropriately sized for the service. Secondly, let's discuss the electrode bonding jumper. An electrode bonding jumper is used to connect different grounding electrodes together to form a grounding electrode system. This is often required when you have multiple grounding electrodes, such as a ground rod and a metal water pipe. The purpose of the electrode bonding jumper is to ensure that all grounding electrodes are at the same potential, which helps to minimize voltage differences and prevent ground loops. The size of the electrode bonding jumper is also determined by the size of the grounding electrode conductor. According to NEC section 250.64. The electrode bonding jumper must be sized no smaller than the largest grounding electrode conductor. Therefore, if the grounding electrode conductor is 4 AWG, the electrode bonding jumper must also be at least 4 AWG. Now let's address the specific question about the insulation requirements for a 4 AWG grounding electrode conductor and electrode bonding jumper. The NEC requires that the grounding electrode conductor and electrode bonding jumper be bare or have green insulation. However, when the conductor is 4 AWG or larger, it is permitted to be installed without insulation. In practice, it is common to use bare copper conductors for these applications. The reason for using bare conductors is to ensure a reliable connection to ground. The absence of insulation eliminates the risk of insulation breakdown or degradation over time, which could compromise the grounding path. Additionally, using a bare conductor makes it easier to make connections to grounding electrodes and equipment. The NEC allows for the use of insulated conductors for grounding electrode conductors and bonding jumpers in certain situations. For example, NEC section 250.64. C specifies that when a grounding electrode conductor is installed in a raceway, the raceway must be electrically continuous from the point of attachment to the equipment grounding bus or grounding electrode to the grounding electrode. The raceway itself must be bonded to the grounding electrode conductor at both ends. This requirement is intended to provide a low impedance path for ground fault current and to prevent voltage differences between the raceway and the grounding electrode conductor. NEC section 250.64. D addresses the installation of grounding electrode conductors. It states that grounding electrode conductors must be installed in accordance with NEC section 300.3, which covers the general requirements for wiring methods. This means that the grounding electrode conductor must be protected from physical damage and installed in a neat and workmanlike manner. It also means that the grounding electrode conductor must be securely fastened to the building structure. In addition to the general requirements for wiring methods, NEC Section 250.64 provides specific requirements for the installation of grounding electrode conductors. It states that grounding electrode conductors must be run in a straight line whenever practicable and that they must be protected from physical damage. It also states that grounding electrode conductors must be securely fastened to the surface on which they are carried. When installing a grounding electrode conductor, it is important to consider the environmental conditions to which the conductor will be exposed. For example, if the conductor will be exposed to corrosive substances such as salt water or chemicals, it is important to use a corrosion-resistant conductor to protect the conductor with a corrosion-resistant coating. It is also important to protect the conductor from physical damage, such as being struck by vehicles or equipment. In some cases, it may be necessary to install the grounding electrode conductor in a conduit or other protective raceway. When selecting a grounding electrode, it is important to consider the soil conditions at the site. The NEC requires that grounding electrodes have a resistance to ground of 25 ohms or less. If the resistance to ground is greater than 25 ohms, it is necessary to install additional grounding electrodes until the resistance to ground is reduced to 25 ohms or less. The resistance to ground of a grounding electrode can be measured using a ground resistance tester. This device applies a small current to the grounding electrode and measures the voltage drop between the grounding electrode and a reference electrode. The resistance to ground is then calculated using Ohm's law. When installing a grounding electrode system, it is important to ensure that all connections are made properly. All connections must be clean and tight to ensure a low impedance path to ground. Connections should be made using approved connectors and fittings. It is also important to protect connections from corrosion. Connections that are exposed to the weather should be coated with a corrosion-resistant compound. In addition to the requirements for grounding electrode conductors and electrode bonding jumpers, the NEC also includes requirements for equipment grounding conductors. Equipment grounding conductors are used to connect the non-current carrying metal parts of equipment to the grounding system. This includes items such as metal enclosures, motor frames, and appliance housings. The purpose of the equipment grounding conductor is to provide a low impedance path for ground fault current and to protect people from electric shock. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. NEC Table 250.122 provides the minimum size of the equipment grounding conductor based on the size of the overcurrent protective device. For example, if the overcurrent protective device is rated at 20 amps, the minimum size copper equipment grounding conductor is 12 AWG. If the overcurrent protective device is rated at 30 amps, the minimum size copper equipment grounding conductor is 10 AWG. If the overcurrent protective device is rated at 60 amps, the minimum size copper equipment grounding conductor is 10 AWG. If the overcurrent protective device is rated at 100 amps, the minimum size copper equipment grounding conductor is 8 AWG. If the overcurrent protective device is rated at 200 amps, the minimum size copper equipment grounding conductor is 6 AWG. If the overcurrent protective device is rated at 400 amps, the minimum size copper equipment grounding conductor is 3 AWG. If the overcurrent protective device is rated at 600 amps, the minimum size copper equipment grounding conductor is 1/0 AWG. These requirements are outlined in NEC Table 250.122. It's crucial to refer to this table to ensure the equipment grounding conductor is appropriately sized for the circuit. When installing equipment grounding conductors, it is important to ensure that they are properly connected to the equipment and to the grounding system. Equipment grounding conductors must be connected to the equipment using approved connectors and fittings. They must also be connected to the grounding system to grounding bus or terminal bar. In some cases, it may be necessary to install equipment grounding conductors in a conduit or other protective raceway. This is often done when the equipment grounding conductor is exposed to physical damage or when it is necessary to protect the conductor from corrosion. The NEC also includes requirements for bonding. Bonding is the process of connecting together the non-current carrying metal parts of a building or structure to create a continuous electrical path. This includes items such as metal water pipes, metal gas pipes, metal conduit, and metal building frames. The purpose of bonding is to ensure that all metal parts are at the same potential and to prevent voltage differences that could cause electric shock. The NEC requires that all metal parts that are likely to become energized be bonded together. This includes metal parts that are within 6 feet of a grounded surface, such as a water pipe or a concrete floor. Bonding must be done using approved bonding jumpers and connectors. Bonding jumpers must be sized in accordance with NEC Table 250.102. In addition to the requirements for bonding, the NEC also includes requirements for surge protection. Surge protection devices are used to protect electrical equipment from voltage surges caused by lightning or other transient events. Surge protection devices must be installed in accordance with NEC Article 280. Surge protection devices must be connected to the electrical system at a point where they can effectively protect the equipment they are intended to protect. They must also be grounded to provide a low impedance path for surge current. The NEC provides detailed requirements for grounding and bonding to ensure the safety of electrical systems. It is important to follow these requirements carefully to protect people from electric shock and to prevent damage to electrical equipment. Proper grounding and bonding are essential for the safe and reliable operation of electrical systems. In summary, a 4 AWG grounding electrode conductor and electrode bonding jumper is required to be bare, without insulation, to ensure a reliable and low impedance path to ground. Always consult the latest edition of the National Electrical Code, or NEC, for specific requirements and to ensure compliance with local regulations. Proper grounding and bonding are critical for electrical safety.